Today's tour demonstrates how use of energy resources and product innovation affect affordable home design. As costs of traditional limited energy sources rise, new technologies are being developed to utilize solar, geothermal, water, and wind power. The 5 Pownal homes on this tour span 5 70-year increments and demonstrate developments in energy sources and conservation. Settlers during the early 18th century came from the Albany area to buy or lease farm acreage. The first home on the tour, the Moore Wright DeVoe, is believed to be one of the original 12 houses from the early Rensselaer-Wick land lease. John Defoe came to Pownal about 1750 from Rhinebeck, New York. His house may have already been built when Defoe arrived. He likely purchased it because of its proximity to the Hoosic River. Defoe built a grist mill used for grinding grains in flour. Several decades later, a covered bridge was built near the grist mill. The Defoe house is believed to have at one time functioned as a tavern. Location of this home was central between Fort Massachusetts in North Adams and Bennington. In 1740, an open fireplace was used for cooking and heating the home. The center chimney design in this home allowed a fireplace in each first-floor room. This design provided significant vertical thermal mass, material which retains warmth in the home. As fireplaces were burning wood, brick masonry would gradually warm, retaining heat. The entire fireplace chimney structure slowly released warmth into the dwelling, providing comfort to early 18th century homes, which were poorly insulated. Many fireplaces were built with brick using local clay. Settlers fabricated bricks on their own property. Sometimes extra bricks, as is the case of the Moore Wright DeVoe house, were placed in the walls for insulation and to keep critters out. Lime was required to prepare mortar, which held bricks in place. Early settlers surely recognized the Pownal lime outcropping just off Route 346. Windows were kept small because glass was scarce and expensive. Quarry Hill Farm was built by Benjamin Gardner, a public preacher, who came from Rhode Island with his family around 1763. An incentive for Reverend Gardner to settle in town may have been land shares offered by Pownal's charter to support a minister. Tradition has it that Benjamin Gardner served at a log church on Mount Anthony Road, but was later dismissed. Benjamin Gardner's brother George also settled in Pownal with his wife and their 11 children. Both Gardners were prominent members of the town, serving in many ways. During the American Revolution, Benjamin was a devoted patriot, while his brother George was a staunch Tory. Both brothers and their numerous descendants are buried in the old Gardner Cemetery. The Quarry Hill Farm home was intentionally sited with the main entrance and many windows facing south, taking advantage of the warmth of the sun during winter. This is called passive solar. In 1820, a major house renovation took place at Quarry Hill Farm that utilized 2 important innovations affecting energy consumption. Benjamin Franklin had improved an open stove, as he said, for the better warming of rooms and at the same time to save fuel. Soon after, another American, Count Rumford, came up with a simple fireplace retrofit that made fireplaces smoke-free as well as more efficient. Modifications were made to the original center chimney during the 1820 renovation. It appears the individual fireplaces were reduced in size and stoves were installed to increase heating efficiency. Some believe Quarry Hill Farm was part of the Slave Underground Railroad that operated before and during the Civil War. This so-called railroad was a network of houses used to help slaves escape to freedom. Homes were called stations, runaway slaves were passengers, and guides were called conductors. The conductors led the passengers from one station to another. One indicator which homes were safe stations was a white chimney painted with a black stripe around it, as you will see at the Quarry Hill Farm home. This house was built in 1890, a time when many significant energy changes were occurring. Coal was being used to operate iron and steel mills, and Thomas Edison had discovered a way to generate electricity from coal. The nation was now burning more coal than wood. Inexpensive fuel and new technology allowed production of affordable house ornamentation products for the working class. Americans embraced expanding and embellishing their homes. Fancy moldings were used on the exterior and interior. Rooms became larger, ceilings higher, and staircases more substantial. Coal furnaces were placed in the basement, with steam piped to individual radiators. Windows increased in size. With the arrival of the first iron cook stoves, the drudgery of kitchen work improved. It took over 1 hour a day to tend a cook stove. However, it was easier and safer than bending over an open fire. Oil was also being used to make kerosene for lighting. Households relied on ice for refrigeration. In the late 1800s, housewives made most meals from scratch using a great deal of flour and other basic ingredients. As a consequence, the Hoosier cabinet was introduced, a forerunner of modern cabinetry. By 1930, the majority of people living in cities had electricity. Electrical appliances began to replace the labor of many household chores. Before 1910, the United States produced between 60 to 70% of the world's oil supply, with growing fear that our oil reserves were becoming dangerously depleted. A bitter struggle for control of world oil reserves erupted. The dispute was resolved when American oil companies were allowed to drill in the Middle East and the Dutch East Indies. America had become dependent on oil. The history of the oil industry has been one of vast swings. By the early 1970s, the United States depended on the Middle East for a third of its oil, allowing foreign oil producers to raise prices and create an oil crisis. By 1981, oil prices fluctuated from $35 to $9 a barrel. To find relief from these cost swings, a young couple decided to build an energy-efficient home. In the late 1970s, Joel and Lydia Johnston saw a ferro cement dome house. They researched constructing a dome house and drew up their own plans. To take advantage of passive solar, many large windows were designed to face south. It would take 12 months to fabricate every part of this home themselves, with a few exceptions, including a poured concrete foundation, the application of a type of concrete called gunite, and spray foam insulation. Post and beam construction was erected for the main supports. A floor was installed over the foundation, and mats of chicken wire were fabricated for the walls. Rough window frames were installed. Freshly cut 2-inch tree saplings were used to push out the wire wall mats, forming the curved design of the exterior walls. A 1-inch layer of gunite was sprayed on the exterior walls, followed by 4 inches of polyurethane insulation. Elastomeric coating was applied over the foam to protect the insulation from degradation. Interior walls were then plastered by hand. This home has never used commercial electricity. Sun powers the 16 photovoltaic collectors that have been installed on the roof for the past 30 years. A propane generator provides power for cooking, hot water, and a backup heating system. When there is no sunshine, a wood-burning stove keeps the house comfortable. Salad greens are grown throughout winter months in a greenhouse that is attached to the south side of the house. Product development is the reason that dome construction was possible. By the 1970s, a method had been developed to apply foam insulation, and materials were perfected, making the foam flexible. In this type house, the continual layer of gunite and plaster creates a thermal mass which insulates heat in the home, or in the summer keeps heat out. Lydia Johnson is a professional artist known for her impressionistic landscapes. In the barn behind her home, you are welcome to view her wonderful paintings. In 2009, energy considerations were the motivating factor in constructing the last home on this tour. It was designed by Pauline Guntlow with George Messina as builder. The goal of the homeowners, Jordan Schell and Anita Lambert, was to use alternative energy in the form of solar thermal collectors to provide both hot water for domestic use and radiant floor heat. Unlike the dome house, which has photovoltaic collectors to produce electricity, solar thermal collectors are used to produce hot water. Photovoltaic and solar thermal are two distinctly different types of collectors and serve different purposes. Heat derived from the solar thermal collectors first heats domestic water and next radiant floors. Any remaining heat warms the thermal mass foundation. The thermal mass foundation is what makes this house extraordinary. Both the Moore Wright DeVoe house and the Quarry Hill farmhouse benefited from a vertical thermal mass, their massive center chimneys. The dome house has thermal mass walls, while this house has thermal mass in a horizontal plain slab floor. Even if the sun does not shine for several days, the floor's residual heat can maintain sufficient energy to keep the house at a comfortable temperature. In case of an extended period of time without sun, there is a backup propane boiler. A solar thermal hot water system is triggered when the warmth of the sun heats glycol fluid which flows through the collectors, similar to the process of a garden hose that sits in the sun. To take advantage of passive solar, the house was sided with its long side of windows facing south. Each main room has at least one window with southern exposure. The finished concrete slab on the main floor absorbs this passive heat. Both passive and active solar thermal systems are greatly enhanced because the house was insulated effectively with foam insulation and exterior insulating wrap. Particular attention was paid to selecting materials which are considered environmentally friendly. Bamboo flooring is one example. By the time Pownal celebrates its 300th birthday, we will likely see traditional house designs remaining popular, but the use of fossil fuels for powering them may be a distant memory.